Okay, so welcome back. We're going to make one last video on savings, and we're going to focus on these two particular things in the question. So first is I% versus OR%, and the second is the start versus the end of the month. So I'll start by explaining this. Basically what I mean is a lot of the time when they give the monthly rate, so I'm going to say that the monthly rate is normally OR%, okay? The problem with having OR% in these questions is that we use OR as our sequences and series thing. So basically the trick is if they give you OR%, basically you're going to change OR% to I%, just because I is always used for the financial maths formula. So F is equal to P1 plus I to the power of T. It's easier to use I than OR, because again OR comes up in sequence and series. That's just one quick thing. The next thing is the start versus the end of the month, so you have to be really careful about if they say the start versus the end of the month, and we'll see that in the example question. It's kind of hard to explain without an example in front of us. So I'll go ahead and I'll start looking at an example now. Okay, so here's our question. Orla wants to buy a car for 25,000. She's going to save for 3 years, and the monthly interest rate OR is equal to 0.6%. How much does she need to save every month? So again, we're going to look at the important info. So I'm going to write info here. So first, the total amount is going to be 25,000. 3 years. So I'm going to say 3 years, and that's equal to 36 months. The interest rate OR is equal to 0.6%, and the last bit, which I apparently forgot to add to the question, I'm going to say end of every month. So sorry about that, I'll just scribble it in here though. So she's saving up at the end of every month, so I'm going to write that in as the important info. End of month. Okay, so here are 4 bits of important info. So 25,000 euro, we can leave that as it is. 3 years and 36 months, that can be left as it is as well. These last two we're going to have to pay attention to. So I'm going to say instead of OR is equal to 0.6%, I'm just going to call it I is equal to 0.6%. It's only a tiny change, but it's just something you should be aware of. And then lastly, end of the month, we're going to keep an eye on that when we start our calculations. Okay, so I'm going to scroll down. I should have enough space there. So now I'm going to start working out the formula that I have this. So again, we're going to pay special attention to the end of month here. All right, so it's different from the last question a little bit. So there are 36 months in total. 36 months in total. The first payment. So first payment, and we're just going to say that she pays A every month. Yeah, just to keep what we've been doing. Pays A every month. So the first payment is made at the end of the month. So first payment is going to be after 1 month. So that means there are going to be how many months left? There should be 35 months left, yeah? So that means 35 months left. So that means that the first payment A is going to have 35 months of interest on it. Okay, so only 35 months and not 36 months like the last one. So that's the main difference. So I'm just going to go through it a little bit, like keep going through it so you can understand how it makes a difference. The second payment is after 2 months. After 2 months. So that means there are 34 months left. And so that means if I do it again in dark blue, that means our second payment A is going to have 34 months of interest. Okay, so hopefully you'll see the pattern. And then the last important thing that's going to keep going, that the last one, so I'll go red, the 36th payment is going to be after 36 months. 36 months. That means that there are going to be 0, so that's just an arrow, not a very good arrow, but 0 months left. Okay, so that means on the last payment, no interest. So I'm just going to say last payment, no interest. And the reason for that is that it's not in the bank at all. So remember, she's saving at the end of every month. So at the end of the very last month, she puts the money in the bank, and then she straight away takes it all out to buy the car. She'll have 25,000 after that. So it doesn't get time to collect any interest. So that's the main thing you need to be aware of when it says at the end of the month, that the numbers are going to be shifted. So instead of the first payment getting 36 months, second payment 35, the first payment gets 35, second gets 34, and the last payment gets no interest. Okay, so now we're going to see how that affects our equation. So remember, we want to write out the entire equation. So we know that, sorry if I go back a little bit, that all of these payments, the first payment, second payment, last payment, I don't have a table here, but they should all add up to 25,000. So we're going to write that in one equation over here. I'll go green. So we know that 25,000 is going to be equal to the sum of all payments, yeah? Sum of all payments. So all payments, okay? So the payments are going to be A, yeah? So she pays that every month, plus the interest they accumulate, yeah? So I'll go that 25,000 is equal to A, and there's going to be all the interest. So if we remember, the first payment gets 35 months interest. So that's going to be 1 plus I to the power of 35, plus the second month gets 34 months interest. So the second payment is going to be A by 1 plus I, 1 plus I to the power of 34, and that's going to keep continuing until we get the last payment, which is just A, right? The last payment is just A because there's no interest on the last payment. So that's what our geometric series looks like. So now I'm going to rewrite it. So remember, you have to flip it. So we're going to have A plus A by 1 plus I plus, and that's going to keep going all the way to A by 1 plus I to the power of 35. So it's a terrible 35. And that should all be equal to 25,000. So that's the main big difference, that this is going to look a little bit different because the number doesn't go the whole way up to the amount of months. It's just one less than the amount of months. So I did go through that quite slowly, but I just wanted to explain why that is. If you want in future, if you see the end of every month, you can skip straight to this step here. All right. So put a little star there. You can skip straight to this step here. If you see that it's at the end of every month, it's just going to be from A to A 1 plus I, and then one less the number of months. That's how many months it's going to collect interest. So now I'm going to write out the formula for the sum of a geometric series, 1 minus or to the power of n, 1 minus or, because that's what we have here, a sum of a geometric series. In this case, A, the first term, is just going to be A, because it's the first term. Or is again going to be 1 plus I, and n is going to be 36. Okay, so there's 36 terms. There's 1, 2, 3, all the way up to 35. But there are 36 terms. Okay, so don't be confused with the little 35 there. There are still 36 terms. So if we want to stick all of that into the formula, we're going to find that we get 25,000 is going to be equal to A by 1 minus 1 plus I to the power of 36, all divided by 1 minus 1 plus I. Okay? And now that you have this, the only thing left to do is to rearrange it and solve for A. So I'm not going to go through the whole rearranging, but what you're going to get is you're going to get that A should be equal to 25,000 multiplied by 1 minus 1 plus I, all divided by 1 minus 1 plus I to the power of 36. Put that into your calculator, you're going to find that your answer is 624.22 euros. That's how much Orla has to save every single month if she wants to buy her car in 3 years. Okay, so hopefully that makes sense. I went through a little bit quicker than the other ones because I think we're getting used to it now. Again, the main difference there, I just wanted to point it out. One, you can change from or to I just to make it a little bit easier, and the start versus the end of the month. So again, the most important line, if it says the end of the month rather than the start of the month, that your equation, where's the blue one down here, is going to look like this here. Okay, so it's going to go from just A to one less than the amount of months there are. Okay, so hopefully that made sense. If you guys enjoyed the video, make sure to like and subscribe and to share with your friends. In the next video, we're going to look at pensions. So yeah, we'll see you then, basically.